translation from English topical chat consisting of conversational data context response pairs, but it is much bigger than Arabic empathetic dialogues. So the auxiliary data should be much bigger than the target data optimally. So in this case, it's about 120,000 context pairs, response pairs, translated using Google Translate API with a high percentage of good translations. Okay, so the solution is also using pre-trained Arab-BERT as encoder-decoder, but also you need to meta-learn the initial parameters, so you have the best meta-learned model for nuanced Arabic dialogue generation to be fine-tuned with the target data set. So they use two algorithms, MAML and Reptile, which they learn how to learn. So with this premise, they're going to learn the best model that is more adept to learn the Arabic dialogue generation from Arabic empathetic dialogues. So it's also going to be more empathetic. And they have measured their success with BLO4 and semantic textual similarity. And they have improved it to the previous state of the art. They used extrinsic evaluation with the fluency and relevance. We are going to use the same evaluation metrics and the novel evaluation method, which is automated and attempts to automate extrinsic evaluation, which is qualitative in nature. So the limitations which we tackle from this baseline is that they assume that there are enough high resource data sets for meta-learning. For example, the auxiliary especially. So there are different applications that you don't have that. In our work, we're going to simulate having a small auxiliary data set. So we're going to take 10% and 30% of the seed data used for meta-learning in the auxiliary and use only 10% of the target data set, which was used in the previous work, to show what can our approach offer in improvements in such scenario. This is an example from Arab topical chat after it was translated to Arabic. Okay, those are some illustrations of MetaDial's approach. This is meta-learning. As you can see in this case, they are trying to improve the parameters of different models, the ones that are most approximate to the desired parameters and that can learn them the best. And this is a diagram of the entire process. So you take this one, represents Arab-BERT in the previous work. Here you load Arab-BERT parameters, checkpoints, and use the different tasks from the auxiliary dataset. And then you meta-learn using Reptile so that you can have all those different parameter updates to have the best parameters. And then you're going to fine-tune on Arab empathetic dialogues after you have the best initial model. Okay, we're going to use also ARA-T5, which is a powerful text-to-text transformer by UBC NLP. It's designed for Arabic natural understanding, language understanding, and generation. It converts every